All right, this little tutorial is going to be a quick one on metallic bonding. So first we're going to talk about what a metallic bond is. Then we're going to talk about something called an alloy. And then we're going to talk about the properties of metals. Okay, so a metallic bond is a bond that occurs between metal atoms. And it's different than ionic and covalent bonding for a number of reasons. So first let's kind of talk about what a metallic bond is. So a metallic bond happens between atoms of metals, and so let's pretend, or let's say that these are metal atoms. The positive charge on the centers is their nucleus, and then of course these are electrons, or valence electrons. So this could be something like calcium, or we'll say silver, right? So silver with one valence electron. And what we have here is a chunk of silver with a bunch of silver atoms that are all kind of, in the chunk. And what happens for a metallic bond is because metals have such low electronegativity, remember that metals have low electronegativity, that they don't hold on to their valence electrons very tightly. So they're going to lose their valence electrons. So once they lose their valence electrons, they go from being a metal atom to a metal ion. So in this case, each of those silvers becomes a silver ion. And then those electrons are free to kind of roam in between all the metal atoms. And so they're actually moving in between all the metal atoms. So if we were to draw little lines that indicate movement of these electrons, they're free to roam wherever between the metal atoms. So metal bonds are often described as metal atoms submerged in a sea of electrons. So all that means is that you've got a bunch of metal ions whose electrons are no longer associated with just one, and then those electrons are able to, or free to roam in the spaces between the metal atoms. All right, so here's a little GIF or GIF file of metallic bonding. So you can see the positively charged ions, metal ions, and then of course the red things are the electrons. So you need to understand that a metallic bond or a metallic compound, there is no such thing as a formula for metallic compound. They don't have a real formula. If you're talking about a chunk of silver, for example, its formula is just silver, and then usually you put a little S next to it to indicate that it's a solid. Or if you have a chunk of aluminum, it's just aluminum, or a chunk of iron is just iron. So there's no real chemical formula other than just the one atom that's in that compound. So let's talk about what about compounds of metals that contain more than one element, like an alloy. So an alloy is when you have two or more metals that are actually just mixed together. So an example of an alloy would be something like brass. Brass is an alloy of copper, and it's usually about 67% copper in composition and 33% zinc. So it would look something like this. All of these atoms would be the copper atoms, and then these yellow atoms would be the zinc. Or you could have something like lead. Lead is also called solder. You guys have probably heard of solder. That's a alloy of lead. And again, it's lead atoms with some tin atoms sort of mixed in. And then sometimes you have something like, say, another alloy that's not listed on here would be something like steel. I'm sure you've heard of steel. Steel is an alloy of iron and carbon. And steel would be something more like this, where you've got iron atoms and then little carbon atoms sort of mixed in with it. So that's an alloy. And you need to understand that, of course, the electrons, so you assume there's electrons that are sort of within the spaces here that are all free to kind of move around in the spaces between the atoms. So last, you need to talk about the properties of metals. So think of any piece of metal that you can think of. So like any of these, brass, which is an alloy, bronze, steel, those are alloys, or you have aluminum or copper, or any metal you can think of that's just a pure non-alloyed metal. Most metals are shiny. That means that they're shiny. They're also mostly malleable and ductile, which means that you can flatten or shape them and they don't shatter. So you can hit them with a hammer and they will flatten out into sheets or into wires. Most metals will react with acid. Ignore the copper chloride part, just most will react with acid. What that means is that you put them in an acid and they'll fizz and bubble. Of course, metals conduct electricity, which is why we make wires out of them. They all have a pretty high boiling point, which means that, and a high melting point, which means, it's hard to melt them. You have to heat them really hot before they start to melt, and then, of course, even hotter before they boil. And then in nature, most are found as a solid, although there is one notable exception, mercury. Mercury is the only one that exists at room temperature in nature as a liquid. All right, that's it. That's everything you need to know about metallic bonding.